Hi, I'm Lily and I'm a PhD student at CSIC, which is the National Science Centre in Spain. I'm based in Madrid with Ali and Katerina, who you'll have seen their YouTube channels around here. So I'm part of a program, an initial training network, and it's called ARGENT. And ARGENT stands for Advanced Radiotherapy Generated by Exploiting Nanoprocesses and Technologies. Now, I'm from Australia and I graduated in physics and chemistry a few years ago, and it's a complete mystery how I ended up in Madrid studying nanodosimetry, but we'll get onto that later. So the title of my project is Bond Breaking as a Descriptor for Nanodosimetry. Now, the reason that I'm looking at bond breaking in regards to nanodosimetry for cancer treatment is because when you irradiate a tumour with radiotherapy or ion therapy, what you're actually doing is sending radiation in and creating a cascade of electrons and radicals and direct ionization that breaks the bonds in the biomolecules within the cell. So you're breaking bonds of DNA, and that's what kills the cell. So it's very important that we understand exactly what happens on a molecular level when you actually irradiate someone, and that's really the aim of my project, is to understand what happens when you use radiation like ion therapy, and especially what happens when you couple it with nanoparticles. So a recent development in the treatment of cancer in research has been to couple nanoparticles, which is any particle smaller than 100 nanometers. At the moment, the most popular ones are made of gold or gadolinium, and what you do is you put these inside the cell and then you irradiate. And this has, I think it's something like a 10-fold increase in effectiveness in killing the cancer cells. So this is really important to understand properly. Now, when you plan treatments for cancer, you actually use computer modelling in order to best attack the cancer and keep the healthy tissue safe. The computer models are based on a lot of calculations and scientific method and other types of modelling, and one thing that you really need to make these computer models accurate is called a cross-section of interaction. So a cross-section of interaction is the probability of, say, a molecule breaking when it's hit with an electron going at a certain speed. Now, my project is measuring and calculating these cross-sections and then creating computer models to track where electrons go in the body once someone's been, in biomatter, once it has been irradiated, and to validate these computer models in a preclinical setting. So I get to do lab experiments where I'm shooting electrons at all sorts of things, and also negative ions, and hopefully looking at radicals as well. And I find out the probabilities of different types of interaction. So find out the probabilities of an electron just bouncing off another molecule, or of it breaking the molecule, or of the molecule getting excited and then relaxing. And there are a number of different processes that occur in this context. And once I have a number of these experimentally, I can start modelling with computers. Now, unfortunately, you can't measure all of the cross-sections that you need, so you do need to use theoretical calculations as well. And that's a part of my project too, is doing some of the theoretical calculations to produce the cross-sections that we need to make better computer models and in turn make better treatment plans. And after doing a number of experiments, calculations, and coming up with some modelling of track structures for radiation in biomaterials, then I will be validating these models in an experiment in a hospital, which is very exciting because I get to just show that everything that I've done for the last 2 years will be actually useful. And the way you validate models in a hospital is to do a type of experiment called a preclinical trial, and the ones that I'm doing will be with water phantoms, where you say, irradiate a box of water and you measure exactly what is happening, or to use biomolecules on a thin film in vacuum. And I'll do a number of videos about the different types of experiments I'm doing because they're quite complicated. Now, after validating the models just for the interaction of electrons and radicals and things with biomolecules, then I hope to add nanoparticles to this mix and accurately model what occurs when you put a nanoparticle in. Because as I said, when you add nanoparticles to radiotherapy, you get a high increase in the effectiveness of the treatment. And it's very important to understand exactly what's going on there so that you can better treat cancer patients. Now, the nanoparticles will need to be added into the computer models, which is quite complex, and they'll also need to be added into the experiments, which is a whole different kettle of fish. And I'm pretty excited about that aspect of it. So that's my project in a nutshell. I hope it's understandable, and I'll see you later on this channel.